Welcome to All This Math. This is Professor Parker, and today we're going to be doing some work using trigonometric ratios, or trig ratios. You might have heard of this mnemonic device called SOHCAHTOA. SOHCAHTOA. So we're going to get into what you use that for and what it represents. Now, the SO part means that the sine function, or the sine of an angle rather, the sine of an angle is equal to the opposite leg divided by the hypotenuse, right, within the triangle. The CA part means that you can take the cosine of an angle within a right triangle, and that would be equal to the adjacent side or leg divided by the hypotenuse. Now, the TOA part, right, because we're dealing with acronyms, right, the T stands for tangent. So that means you can take the tangent of an angle, and that's equal to the opposite side divided by the adjacent side. Now, when I say like the tangent of an angle, the sine of an angle, the cosine of an angle, all that really means is like that's something that you can calculate, right? It represents a ratio. And it's something that you can calculate using a calculator. And we use 4-digit decimals, all right, to deal with the sine of an angle, the cosine of an angle, or the tangent of an angle. We use 4-digit decimals. All right. Now, in this particular example that I picked out, we're dealing with a right triangle. How do I know it's a right triangle? Because of this little box right here. That little box implies that this is a right triangle, right? With a 90-degree angle. Now, what our job is to do is to find out the length of this missing leg in this right triangle, right? That's why the X is here. It's an unknown value, right? We're going to figure it out, right? But the first thing you want to always think about when you approach a problem like this is like, first of all, what do I not know? In this case, we don't know X, right? What X actually is, and then what do I know? All right. So there's a couple things I do know. I do know this is 15, and this side of the triangle has a specific name to it. It starts with an H. You probably know what it is. It's directly across from the right angle, so that's going to be our hypotenuse. Hypotenuse. All right. That's an important term that we should all know. If you don't know what a hypotenuse is, the hypotenuse is the side within a right triangle. It's the side that's directly across from the right angle. So it's not this side and it's not that side. It's across from the right angle, right? And it's the side in the triangle that does not touch the right angle or does not serve to create the right angle. These two sides create the right angle. The side across from it is the hypotenuse, right? Now, I also know this angle. I got a 52-degree angle, right? So I know the hypotenuse, and I also have an angle. Now, here's the thing. Look at the side that you don't know, right? You got to think to yourself, what is the relationship between the angle that I know and the side that I don't know? You got to ask yourself, is it opposite from that angle? Is it adjacent to that angle? Is it the hypotenuse? It's not the hypotenuse because the hypotenuse is across from this angle, right? Across from the right angle. This is the hypotenuse right here, right? 15 units long, all right? This side right here, it touches this 52-degree angle. So that makes it adjacent. Adjacent. Adjacent like right next to. Like when you're sitting in class, the person that's next to you, they're sitting adjacent to you, right? So what we don't know is our adjacent side in the triangle, all right? So now, this information is going to be used to help me pick out, and again, this is the mental process that you go through, that you're going to develop a habit of going through as you're doing any problem that looks like this, right? Which of these trig functions am I going to use to figure out what I don't know? Am I going to use the sine function, the cosine function, or the tangent function? Now, I don't know the adjacent side. So therefore, I know I got to use one of these two because the capital A stands for adjacent. The sine function does not deal with adjacent sides. So we know that sine is not involved in this conversation, right? Now, I know the hypotenuse and I know an angle. Now, you got to know an angle to use any of these, right? But I know the hypotenuse. So I got to pick the one that includes the hypotenuse. Tangent, you got to go because tangent doesn't deal with the hypotenuse. Tangent only deals with the opposite side and the adjacent side. Boom. So I know I'm using the cosine function. I'm going to use the cosine function because the cosine let's say theta. Theta is just a letter we're going to use to represent the measure of an angle. Cosine of theta is equal to the adjacent side, the length of the adjacent side, divided by the length of the hypotenuse. All right? And I know the hypotenuse. I don't know the adjacent side, but I do know the angle. The angle is 52 degrees. And I'm going to use my calculator to figure out the value of the cosine of 52 degrees. So I can create my equation because, again, the goal is to create an equation, right? But we have to be able to look at a picture, take the information from the picture, and create our own equation. All right? So now, what I'm going to do is I'm going to take the information I know. And actually, I want to address something before I go on. Because this can create confusion, right? In terms of what the adjacent side is. Because somebody might say, well, but check this out, though, Professor Parker. You said the 52-degree angle has an adjacent side, which is right here. Wasn't this side adjacent to the 52-degree angle also? Yeah, you know what? You're absolutely right. This side is adjacent to it. But because this side is also the hypotenuse, the fact that it's the hypotenuse cancels out the fact that it's adjacent. So when we talk about adjacent sides, we're talking about either the other two sides of the triangle, but not the hypotenuse. The hypotenuse is never the adjacent side. You might want to put that in your notes. The hypotenuse is the hypotenuse. The hypotenuse is official. It stands alone. It's its own situation. The hypotenuse can never be the adjacent side, even if it technically is adjacent to the angle. All right, just keep that in mind. Now, let's get back to this. Let's go back to this formula, right? So I got the cosine of an angle. That's the Greek letter theta that represents angles, right? So my angle is 52 degrees. So I'm going to do cosine of 52 degrees, right? That's equal to the measure of the adjacent side. Do I know the length of the adjacent side? No, I don't. It's x. So I'm just going to write x right there. Divided by the hypotenuse. Do I know the length of the hypotenuse? Yes, I do. It's 15. Right there. So I'm going to put this right there. All right. So now I got my equation set up. The cosine of 52 degrees is equal to x divided by 15. All right. So then, normally, if I hadn't done this work already, I would take out my calculator. I would find out the cosine of 52 degrees. And the cosine of 52 degrees, again, we round it to 4 decimal places. Your calculator probably give you a whole long list of digits, probably 10 or 12 or whatever. We round it off to 4 decimal places. So it's going to be 0.6157, right? And also in your calculator, make sure your calculator is in degree mode, not radian mode. That's another thing. Because if it's in radian mode, it's not going to give you the proper measurement, right? So now, that's equal to x over 15. So now I'm just doing algebra 1 now. Now I'm just doing an algebra 1 equation, right? I'm trying to get x by itself on this side of the equal sign. So the way we do that is we got to think. If I'm trying to get x by itself, what is on the right side with x that I need to get rid of? This 15. Now the question I have to ask next is, how do I get rid of that 15? Now, when we're solving equations, we either undo things, or you can think of it as like just doing the inverse or the opposite operation. Ask yourself first, what is 15 doing right here? 15 is being divided. 15 is being divided. So we ask yourself, what's the opposite of dividing something or being divided? Multiplying something is the opposite. And since multiplying something is the opposite, that's how I get rid of 15. So over here, I could do times 15. Matter of fact, I don't want to cause no confusion because we got a decimal point right here. And this is supposed to be a multiplication sign. So I'm going to do this. I'm going to use parentheses. Boom. So I'm going to multiply by 15 over here. And I'm going to also multiply by 15 over here. Because also within an equation, whatever we do on the right side of an equation, we also need to do on the left side of an equation. So what happens over here is because we end up with 15x over 15. And the 15s basically cancel out. That's how we get x by itself. Right? Now I go back to my calculator because I don't do this using mental math. 15 times 0.6157 is going to give me 9.2. And a bunch of decimal places, a bunch of numbers after the decimal point, after the 2 and everything. But I'm going to just round it to 9.2. So that means that the length of this adjacent side is 9.2 units. Right? Now, let's say you wanted to do this a different way. You didn't want to just multiply by 15. Let's say you wanted to kind of like carry it like as if it was a proportion. So let me rewrite this. Matter of fact, we'll grab a different color so you can distinguish between the two methods. So let's say I rewrite the equation, right? I got 0.6157 is equal to x over 15, right? Now, I can make this look like a proportion, which is one fraction equal to another fraction, by making this look like a fraction, just by putting a 1 underneath of it. And then I can cross multiply to eliminate the fractions. So then I have 1 times x, which is x, and I have 0.6157 times 15, which is essentially the same exact thing I had up here, except it was written differently, right? So now I go back to my calculator, and the answer is going to be the same. It's still going to be 9.2. So this is just another way to get that answer, another way to get 9.2. And also, you definitely want to like consider, like, is my answer reasonable? Another thing that we should always know about right triangles is that the hypotenuse is the longest side in the right triangle. So if you notice your hypotenuse is 15, and then you do your work and everything, and one of your sides, one of your legs is longer than 15 or more than 15, you know you made a mistake somewhere. So you need to go run it back and go figure out like where your error is. All right. So like I said, that's just a little bit about SOHCAHTOA, a little bit about, you know, how to use algebra when solving for missing sides in a right triangle. And that's about it. Thanks for tuning in. Please like the video if it was helpful. Subscribe to the page. Tell some people about it. Share the wealth. Send this video to somebody else. All right. Thanks for tuning in.